Welcome to my presentation titled Effects of Long-Term Meditation Practices on Sensorimotor Rhythm-Based BCI Learning. The Sensorimotor Rhythm-Based BCI is a technology that could help people perform motor control using motor imagery without actual movement. Using the recording of EEG, it operates by detecting event-related desynchronization and event-related synchronization, which are decreases and increases in power of EEG mu rhythm band that accompany motor imagery and rest, respectively. The SMR BCI has a lot of advantages, such as high temporal resolution, easy to use, and low costs. But challenges remain. For example, it usually requires several training sessions for a subject to fully learn how to perform SMR BCI control, and around 20% of subjects could not generate recognizable EEG signals to perform this task, termed BCI inefficiency. Meditation is a mental training method which has been shown to improve attention and awareness, which in turn are important components of BCI control. Here, we test the hypothesis that people with long-term meditation experience would demonstrate better SMR BCI learning. We recruited 16 experienced meditators with at least 1 year of frequent and consistent meditation experience. We also recruited 19 meditation naive controls. In the analysis, we excluded outliers whose BCI performance deviates from the median. Each session began with a 5-minute warm-up task of left or right hand motor imagery by focusing on imaging the sensation and intention of opening and closing the left and right hand. After that, the subject was asked to perform BCI cursor control of 3 different tasks: left-right, up and down, and tilde, by moving the ball to the corresponding bar with motor imagery. We quantified the performance using percent valid correct, or PVC, which is the ratio between the number of hit trials and the number of hit trials plus the number of missed trials. We found that meditators achieved numerically better performance compared with control subjects in all 3 tasks: left and right, up and down, and tilde. And this difference was consistent throughout the 6 sessions. However, we did not find the learning speed to be significantly different between the 2 groups. The competency curve describes the percentage of subjects passing the BCI inefficient threshold as learning goes on. We set the BCI inefficient performance threshold as 70% for 1D control and 40% for 2D control. After 6 sessions of learning, the percentage of subjects passing the threshold appeared to be higher in meditators, indicating there were numerically less BCI inefficient subjects in meditator group. The next step is to evaluate the neurophysiological differences between the 2 groups. The first is SMR predictor, which has been used to suggest resting mu power predicts BCI performance. We first showed that the existence of such correlation, and then demonstrate that meditators had a higher SMR predictor than controls. The second is the control signal contrast during a task, indicating the ability to create strong motor intention. We found that meditators exhibited numerically better control signal contrast in up and down task. In this study, we have examined the behavior and neurophysiological differences between experienced meditators and control subjects. We found evidence supporting that long-term meditation experience could influence SMR BCI in terms of averaged performance, SMR predictor, and control signal during task execution. This finding has implications on enhancing the brain side of SMR BCI and may help overcome the limitations of SMR BCI technology, such as long training time and BCI inefficiency. Thanks for your time watching this presentation. Hope you enjoy it.